Hello and welcome to the MLOps Minute. So in this episode, I'm going to talk about preparing the data so that we can finally train our AI. But that's not all. Here we go. Remember, in production, we're going to want to expose an API that will receive in real time PDFs as input. In this API, we'll need to extract the images from these PDFs. And on each image, we'll have an AI that will classify whether each image is a cat, a dog, or something else. And as an output from our API, we'll have a list of results for each image. In theory, and what needs to be done in practice, to train an AI, imagine that we have 20,000 images. We'll need to create 3 sets of data. We'll keep 2 sets of data to train the model, a train set with 13,000 images, and a validation set with 4,000 images. These images will be used by the model to train on them. We'll need to keep a set of test images which will enable us to validate that the AI has not learned by rote, i.e. that it will be able to generalize, to continue predicting on data it doesn't know. But that's not enough. Remember, what happens is that in production, we give our API PDF, and so it's a little more complicated because how do we want to work today? We want every pull request. We need to be able to validate production and training. We want for every pull request, if we want to be able to merge on our main branch, validate that we have exactly the same predictions between production and training. If we have an input data set of 10,000 PDFs, we'll probably have over 20,000 images available. Imagine we have this set of 10,000 PDFs at our disposal, and we have over 20,000 images available. We'll need to set aside 20,000 images to train our model with our 3 sets for this. And what we mustn't forget is to keep a set of PDFs, not images, for integration, which we'll use to validate that we've got the same statistics in training and in production. This is very important and is often overlooked. Another very important point is data distribution. It's important to remember that we humans learn from experiences. When you're a baby, you hit yourself on the wall. After a while, you realize that it hurts, so you stop banging on the wall and pay attention. Chances are that AIs too, in our case of AI, where we're in supervised mode, i.e. we give it fixed data sets to learn from, we'll be able to make a correlation. If I tell you a cat, you can memorize what a cat looks like in your head, an image of a cat. And if I tell you what a cat sounds like, you can imagine a cat meowing. If I tell you a platypus, it's a little harder to know what a platypus sounds like. And if I tell you what a platypus sounds like, I personally don't know. So this is a picture of a cat and a platypus as ChatGPT displayed to me. It's up to you to see if it's true or not. And so for an AI, it's going to be a bit like us. In other words, if out of a set of 10,000 PDFs, 1% is a cat, 20% is a cat, a dog, and all the rest are images of others, well, the AI won't have had much experience of cats, and it's likely to be much harder for the AI to be able to predict a cat. So it's very important to distribute your data properly. So what are we going to do in this data splitting stage? We're going to create 4 directories. First of all, we're going to take an integration directory. extract PDFs and the images associated with each PDF. This will enable us, during this training phase, to retrieve all the predictions for each image in these PDFs and keep these integration PDFs, which will enable us to validate the production stage, and that's very important. Here, framed in orange, are my 3 data sets: train, validation, and test, in which cats, dogs, and other items will be stored in 3 subdirectories. And what's going to happen is, imagine I put 100 images of cats here. We'll try to put 100 images of dogs and 100 images of others. In other words, we're going to put as many experiences of cats, dogs, and others. That way we'll be really square, and our AI will have a good, even distribution of data, and chances are it will learn better. So we'll try to put the same number of cats and dogs in these 3 directories. And that gives us our training pipeline today, which looks like this, i.e. we have our PDFs as input. We extract flat images from all these PDFs. We're going to want to have these images as input to the data split, but as we want an integration PDF, as we want to extract PDFs to run integration tests on our production, we also need to point to this data set for our data splitting step. And remember, in previous episodes, we annotated the data. So from our annotations, which come from images and not PDFs, we'll be able to, for each image, know in which directory to store the data, because we have the right annotation associated with it. So when we do the code in the previous episode, in the next episode, something very important will happen, is that we're going to add a notion of randomness, i.e. we're going to make the data random, but not completely. In other words, in Python, there's a seed function here, which will allow us to freeze a random, because we want it to be reproducible when we play our data pipeline. We want it to be reproducible. And by freezing the seed here, the random function will always give the same result every time we play an experiment. This means that when we iterate to train our model, we can vary this seed to see the different results it produces. On the other hand, once we want to freeze our pipeline, we'll leave this seed so that we always have the same output in our data split step each time we have the same inputs. So we want this step to be reproducible, and that's very important. So there's a question you're going to ask yourself, but how much data do I need to train my model? Well, that's going to depend. In other words, for our case with our cats and dogs, we're going to start with a model that's already been trained, a VGGXV, which has already been trained on millions of images, thousands of images with cats and dogs. As a result, we're going to see that 100 images is enough to get good results. On the other hand, if you want to start from scratch, to make a lighter, more powerful model, you're going to need a lot more images. And it's also going to depend on your use case, because if, for example, you're in a factory on the way out, you've got a camera on the way out, for example, of a telephone manufacturing plant to do quality control, I don't know, of the screen. You'll probably always have photos taken at the same time with the same light, with the same size phone. And you'll probably need less data than if you have to take phone images in all the contexts of everyday life, from very far away to half hidden with different immodity, etc. So the amount of data you need will depend on what you need, quite simply. that's all for this episode, which is quite rich in information. And in the next episode, we'll be talking about data spitting again, but this time, how to put it into practice. See you soon.